Okay, we are back. I'm very happy to have on the Goldstein on Gelt Show Professor Tomas Lindahl, who is one of 3 professors this year to have won the Nobel Prize in Chemistry. Professor, real honor.
Thank you.
So the actual topic that you were awarded the prize for is what they called mechanistic studies of DNA repair. But what I'd like to do is I'd like in our discussion today to talk a little bit about what the work is and then to talk about the practical implications, to go sort of from the theoretical to the more practical. And one of the things that I've heard you have said is that cancer is being treated with drugs that could actually cause genome instability. It sounded very frightening when you said it. Am I misunderstanding it, or is there something scary going on here?
No, that's correct. You have to treat cancers, and a well-known example is with radiotherapy. That means you expose patients to ionizing radiation. And you don't expose healthy people to ionizing radiation. But in this case, it has since many years been known that ionizing radiation kills cancer cells very effectively, while the patient cells survive reasonably okay.
The risks of radiation, frankly, sound quite worrisome if you damage the patient more than you damage the cancer. Is this a fundamental problem with that approach to dealing with cancer?
It's not a fundamental problem. We have known about radiotherapy for a long time. If you do nothing, the patient will die because the tumor will grow. You can kill the cancer cells with radiation. And when you do that, in some minority of cases, there is a risk for the patient too.
You've also spoken about the instability in cancer cells, and in fact, you've suggested that we could exploit that instability in order to deal with and perhaps, well, I'd like to say, hopefully cure cancer. Is this something on the horizon?
I think so, yes.
So a young man like myself, should I be not too worried about getting cancer in my older years?
Well, cancer is an old age disease usually. So, and we are not going to live forever. So you will die from something, and that could be cancer or a number of other things.
So explain to us the implication of your research and how it might be applied in the world of medicine.
Well, the implication of the research is that we have to understand that our genetic information is not as stable as people have thought before. DNA is not made out of stainless steel or marble. It's a more labile structure, and that makes it vulnerable. That's part of life, and there's nothing we can do about that.
Okay, so once we understand that, what are some of the steps that we should take? For example, your work has to do with DNA repair. Is this very futuristic, where when someone discovers that he has a problem with his DNA, it can actually be fixed?
Well, as always in biology, you first have to understand the problem. You see, so that is a large part of our contribution, just to understand what goes on in cells. In the same way that a physicist needs to understand how atoms and molecules are put together. It's not something you can immediately make money on or cure somebody with, but we need that knowledge to understand the world we live in.
We're talking with Professor Tomas Lindahl, the 2015 Nobel Prize laureate in chemistry. And based on the work that he's done with DNA, as well as the focus on the human genome, Professor, tell me, there was billions and billions of dollars that was invested in mapping out the human genome. How has that influenced your work? And what I'm looking for is, sort of where I'm leading with the question, I'll cut to the chase, is should that kind of money be spent by governments? Is that an effective way to forward research to help medicine?
Yes, I think this is a very well spent money to understand our genome better. We have to start with knowledge, and once we have the knowledge, we can devise new cures for diseases, for example.
This was sort of a shotgun approach. In other words, spending so much money to do this research, as opposed to, for example, setting up certain incentive prizes or focusing on very specific work. If we're looking to develop a cure for cancer, which I understand is really where your research could be directed, Is there a more effective way for people to be investing in this?
I don't think so. We have to build up our knowledge base for a start. It goes back all through science. A generation back, children would suffer from polio, and there wasn't very much we could do about it, except doing more research, which established that there is a polio virus and that you can make a vaccine against it, and then you have actually, to a large extent, cured the risk for the disease. If you don't do the research, you will have nothing to start with.
Mm-hmm. Any hope that we will have a vaccine for cancer in the foreseeable future?
Cancer is not just one disease. It's probably 100 different diseases. It means one of our cells starts growing in an unregulated fashion. And that can happen due to a variety of mutations. So I don't think we will be able, within the foreseeable future, to have some wonder drug that will cure all kinds of cancers. We have to tackle different forms of cancer and treat them individually.
It seems that a lot of the funding that goes towards research like yours is determined very politically, depending on what one government feels it should be focusing on, not necessarily for the number of people that will be helped, but because of something that just might be going on in terms of politics or the electorate. Did you feel an effect of that, or do you feel that money is being properly distributed where it's most needed in the world of science?
I think the money at present is well spent because it's being building up our knowledge base. In addition to that is also a lot of work on practical aspects, which I guess is what you are asking for, immediate short-term solutions to specific problems.
And are there any specific places or companies that you feel are really excelling in the area now that we should be looking at?
I don't want to comment on individual companies.
Okay. Well, then we will certainly have to hope that your research gets shared far and wide. The research actually that you won the prize for was what you had done many, many years ago. Is that correct?
That's right.
So I know there's
it's a long-term effort. It's still ongoing, but we started it several years ago, many years ago.
Could you share with us a little bit of what your main focus is today?
Yes, we are continuing defining different forms of DNA instability to make our knowledge base more comprehensive.
All right. Well, we will continue to watch your research. Professor Lindahl, I first of all like to thank you very much for taking the time to talk to us. What is the best way for listeners of the show to follow your work and to keep up with what you're doing?
Well, there are excellent scientific journals on the web and so on. You can popular science or the original papers if you have knowledge to read them. And just by reading and trying to understand is a good base.
Okay, fantastic. Listen, thank you very much for taking the time talking to us today. I know that you have a very busy schedule, and I look forward to following the research you're doing and all the help you are doing in the world of medicine and DNA.
Okay, thank you.
You've been listening to the Goldstein on Gelt Show with money maven Doug Goldstein. Doug's weekly radio show is heard around the world, but if you miss it, you can download the podcast at www.goldsteinongelt.com. The Goldstein on Gelt Show gives you up-to-date financial ideas so you can get on the path to financial freedom. If you'd like your questions answered on the air or off, send Doug an email to doug@profile-financial.com. It's your money for your future, so join Doug every week to build your wealth on the Goldstein on Gelt Show.